Good day, ladies and gentlemen. In today's session, we're going to discuss exactly how to solve evaluation 2 for ES216AB. So we're going to read through the question paper and I will discuss exactly how I would approach solving all the questions that were stated in this question paper. So let's read the question paper. To complete the functionality of the random array frequency graph display C programming application, several functions are needed. These functions must be defined in separate .h header file that is linked to the provided.c programming file. So let's just quickly go. This was the files that was provided, and this is the .c file. So here we can see the .c file. So I've opened that. And then there's a note, your header file should be named studentnumber.h. You must update the include statement in the provider.c file to successfully link your header file to the provider.c programming file. Okay, so what we can do there is I'm just going to make a copy of the template studentnumber.h file that was also given, and I'm going to name this just 2, 3, 4, 5, 6, 7, 8, 9. That's going to be my student number for now. And I'm going to open that. So back to the question paper, it says it must be named your student number, and then important, you may only change the include library header file statement in the .c programming file. All other code in the C programming file must remain unchanged. So the one thing is we just need to ensure that we change our include statement here. So the include statement for our header file needs to be 1, 2, 3, 4, 5, 6, 7, 8, 9 .h to ensure that it's going to link correctly to this file here. So I've already changed that. So this is my C file that's provided, and we're not allowed to change anything other than this include statement. So the rest of the code is going to be generated inside of this template file here. So let's continue. So the random array frequency graph display application requires the generation of 100 random values between 0 and 99, which are stored in the random data array. Subsequently, the frequency of each number group, as explained in detail below, must be calculated and stored in the frequency data array, and the frequency data array is linked to another array called frequency index, which stores the number of groups for the frequency data. Okay. So there's basically two arrays and they are connected. We've got one that's frequency data and one that's frequency index. Once the random values have been generated and the frequency of each number group calculated, the application will display a menu with the following options: graph sorted by index, graph sorted by frequency, data statistics, and exit. So if we quickly have just a quick look here, we've got frequency data there and we've got frequency index. That's our two arrays. You can see frequency data was already declared, or not declared, but initialized to 0. So all the elements are initialized to 0. We've got our first function call here, generate random data. Second one is calculate data frequency. And then we've got our menu options, and we are basically calling bubble sort twice here, and then display graph, that's function 3 and 4. And then we've got average, minimum, maximum, that's function 5, 6, and 7. So this program, the C file part, is already created for us. Okay, so then we go into the questions of our, just want to check. Oh, we can really just check here. Options 1 and 2 allow for the sorting of data either by frequency data or frequency index. For further clarity, please refer to the provided showcase exe file and the application print screen in Annexure 8. The functions you complete must enable the application to produce the output shown in the print screens and provider.exe file. So we've got our functions here. Function 1, 2, 3, 4, and 5, 6, 7, and 9. And then if you go all the way down, this is where we got the annexures. So basically, you will see here it's going to display the menu for us after we have generated and calculated the frequencies. And then if we select option 1, it's going to say graph sorted by index. So meaning we've got those two arrays. Index is, the values are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the frequency data correlating to that specific index is going to be displayed. If we press 2, we're not going to sort the two arrays according to the index values, but rather to the frequency data values. So you will see that the frequency indexes are unsorted, but the frequency data values are sorted from the smallest frequency to the largest frequency. And then we've got just option 3 that's going to give us some statistics and still display the frequency index and frequency data values for us. And then 4 is to exit. So if I go all the way up here, all 8 functions here is going to give us then the actual implementation. So what we need to do is we need to go and create all these functions so that we get to the actual result as discussed. So if we go on here, just after the functions, I'm going to discuss each function separately, but if you go on, the instructions are for adherence, proper adherence to provider instructions, control structures, naming conventions, and structured programming principles is crucial for obtaining full marks. Even if the program functions correctly, it does not guarantee full marks. Proper indentation comments are essential for clarity and understanding. No global variables may be implemented in the final solution. And here we've just got that explanation as I discussed with print screens. So what I would suggest is, if you get a question paper like this, is to go and set up your header file and your C file so that you can get it to run before you start actually programming stuff. So if I run this C file, what you will see here at the bottom is it's going to have a few undefined references to all these functions that we need to go and create. Because the C file is basically calling functions that does not exist at the moment. For instance, the generate random data function doesn't exist. It's trying to call this function, but it can't get a hold of this function. So we need to go and implement this. So in your .h file, what I would suggest is you first need to go and create these functions. So inside of your PDF, what you will see here is you've got all these functions, and then you will be able to go and basically go and copy and paste these void generate data, int array, int size, calculate data frequency, etc. So our first step would be then to copy the first function, and the first function is going to be then this void generate random data function. So this function we need to go and implement. So we use this function prototype to go and implement it. Then we're not going to code the body of this function yet. So I'll show you exactly what I want you to do. So I'm just going to quickly go and create these functions. So what you will see is I can quickly just create these functions. So we've got bubble sort, and then, okay, so function 2 is our calculate data frequency, and then our bubble sort. So I'm just quickly going to create these functions. Function 4 is our display graph function. So all the way down here, oops, forgot that. Close bracket there. So we've got display graph. Function 5 was our data average function, and data average function we're going to quickly go and create. All the way down there. Function 6 is our data min. And we declare that one there. Number 7 is our data max function. And then function 8 is our display array function. So we're just going to basically go and create these functions. So after I've created all these functions, I can go and save this header file. And what I can go and do is I can go and select build and run. And what will happen here is I can now technically go and run this program. It compiles, but it doesn't really do view anything yet. So as you can see, if I select the options, it's maybe showing me some weird data from the data statistics. And for the graph sorted by index or the graph sorted by frequency, it doesn't show me anything. So it's not working actually as it should. So after I can actually build and run my application, only then can I actually start to go and create my functions. So let's start with the functions and see what we can go and do. So I'm going to go all the way up. And the first two functions that is being called is function 1 and function 2. So let's quickly go and read through it. So the generate random data function initializes an array with random numbers. This function takes two parameters, an integer array ARR and a size of this array size. It uses the srand function to set the seed of rand function based on the current time. It then populates the array with random integers between 0 and 99, iterating from 0 to size minus 1 in the array, and assigning each array element a random number between a random number modulo 100. Okay, so I've actually given you the answer there. So the first step is we need to go and randomize. So srand is our randomize function that we will call, and we will use time with the parameter null to actually go and initialize the rand function so that we can generate more random values. After we've done that, we know that when we call the srand function and the rand function, we need to go and include the standard library.h that was already included for us, so we can just confirm that. And if we want to use the time null function there, we need to go and also include time of h, that's also included for us already. So after that, we need to go and basically use a counter variable to go and traverse through each element in this array. So basically, we're going to traverse through each element of the array, and this array is, the size is defined by this parameter. So this function doesn't actually know what's the size of the function, it just knows what's the parameter, and we're going to use that to then traverse through this so that this function is able to adapt to different sizes. So we're going to traverse from 0 to size. I is smaller than size, so size not included, so that means it's size minus 1, and then we're going to increment the counter. So that basically conforms to the 4 golden rules for counter-controlled repetition, where we need to have a counter variable called I, we need to initialize it, we need to have a stop point, that's our condition, and we need to go and increment. Thereafter, we need to go and actually populate random values into each index. So we're going to say for each index I, we need to go and generate a random number. And because this rand function generates a random number between something and something that we don't really know yet, we can use some mathematics, and we use the modulo or the remainder operator that basically works like divide, but it just gives us the remainder. So if we divide by 100, the remainder in integer form is going to be anything between 0 and 99. So we say percentage 100 for that. So we can go and save this and just check that everything is working as it should. So we can run and we will get some output there as well. So nothing else is going to work at this point as well. After that, we need to call the calculate data frequency function, and calculate data frequency function is going to basically determine the frequency of each number. So I'm just going to zoom in a little bit here. So what we can do with the calculate data frequency function is we still need to go and traverse through each element in this array, and when we traverse through each element in the array, we're going to update the frequency array accordingly. So let's quickly go and read through it before I actually do the memo there. So the calculate data frequency function calculates the frequency of data values grouped by tens. It requires 3 parameters: the data array data, its size, size d, and the array frequency. for storing the frequency of each group as shown below. The function iterates through each element of data using integer division by 10 to categorize the elements into one of the bins. So 0 to 9, 10 to 19, etc. So what you can see here is frequency index 0. So the array frequency index 0 is going to store the frequency of values that's between 0 to 9. Index 1 is going to store the frequency of values between 10 and 19, etc. So what we need to do is we need to traverse through each element in this array, and we can use the size d variable, and then we are basically traversing through each element. So what we can go and do is we can go and use, we need to update this frequency values there, and what we will do then is we will basically use the data array to update the frequency array. Okay, so if we go and basically use our data function, data array, if we go and select that index of the data array and we divide it with 10, what we will have is, let's say perhaps that data I, so let's say data index 0 is 9. If we divide 9 with 10 and both of these values are integer, we will get to a value of 0. So that's going to be index 0. If we've got a value maybe 23 and we divide it with 10, we will get a value of 2 and not 2.3 because it's an integer divided by integer. So we will have a 2, and that's actually the index that we need to update. So basically what we will just need to do is just go and increment for that specific index. So it's kind of like a very shorthand way of doing this. And lastly, the one thing that we just need to confirm is before we update the frequency indexes, we just need to make sure that they are defined or initialized as 0. So as you can see there, each index value inside of this frequency data array is 0. So we don't have to really go and worry too much. Okay, so we don't have to go and initialize or reinitialize all the values inside frequency. It's already been done, so we just need to go and determine the frequencies. So that is basically it for calculate data frequency. Okay, so after we've got the frequency, then we can go and actually use or do bubble sort. So let's quickly go and read. So the bubble sort function sorts an array AR sort and simultaneously reorders a secondary array ARR connect to maintain the relationship between the two random arrays. This function is implemented using the bubble sort algorithm, which compares the adjacent elements and swaps them if they are in the wrong order. This is repeated for every element in the array, ensuring the array is sorted from smallest to largest by the end of the function. Both arrays are size. No printf or scanf statements may be used, and here I've given you actually the pseudocode to enable you to do that. So bubble sort algorithm, if you know it, actually quite easy. So we need to have outside for loop that's going to traverse from 0 to size minus 1, not included, size minus 1 not included, so it's going to be of size minus 1, and then we increment, and then we have another for loop that's going to go from j is equal to 0, j is smaller than size minus 1, j plus plus, and then we've got an inside if statement here, and this is where we will ask if this array sort the j value of it, if it's bigger than array ARR sort with j plus 1. Okay, so if index j is bigger than j plus 1, then we know that we need to go and swap. So this is exactly what we need to go and do now at this point. So what we need to go and do is we need to say hold is equal to array sort, and let's use J, and then we know that we need to say array sort is, oops, just the index, and we need to say array sort J, or index J value is then equal to array sort the J plus 1. Okay, and then after that we can go and update index J plus 1 with old. So basically, or effectively, we've swapped the two values around. Now what we will need to do is also swap around the adjacent, or the array that's also sent to this function that's basically got a relationship with the sort, and we need to update that also accordingly. So basically we will just need to go and redo this whole thing. We can just go maybe copy and paste this, and we just need to go and do this for the ARR connect as well. So what I can do here is I can just go and change this to ARR connect. So basically I'm swapping the sort and also the ARR connect arrays. And that's basically what we need to go and do. Okay, so this pseudocode explains just that. We need to sort for ARR sort, and we need to just swap around ARR connect so that it keeps the relationship between the frequency data and the frequency index. Thereafter, we need to go and actually display our graph to the user. So the display functionality is just going to be basically traversing through our array, and then also just display it as it should. So first of all, we've got this char text parameter, and that's basically the heading of this array. So what we will need to do is we will just do a printf statement and %s, and you can do it 2 new lines, and we're just going to display the text as a heading. Okay, after that we need to go and do a for loop, and this for loop is going to traverse through each of the data or frequency data, and I is going to be smaller than the size, and then we're going to say I plus plus. After that, basically we will just go and first display the index value. Okay, so the index value is going to be basically this nice little %d there, and after a tab space and a vertical line, we will basically then just go and display the index value at that point. Thereafter, we do a for loop, and this for loop we're going to use a different counter variable, and this counter variable is going to be from 0. This counter structure is going to iterate from 0 to the actual value that's stored in the array. So that's going to be ARRI. So that's going to determine how many stars that we actually need to go and display. So a printf statement, and then we will basically just go and display 1 star. After we've displayed the stars, we need to go to a new line before we can do another index with data. So we're just going to add a new line at this point. After everything, after our display, we can just add another new line just for nice styling. So if I can save this, after this point we can use build and run, and we can see where's all my mistakes. There's maybe a quick typing error there. Now I can build and run this, and let's see what's going to happen. So now you can see it's actually displaying the graph sorted by frequency index, and then the graph sorted by frequency data. So you can see here, this is unsorted, but this is sorted from small to big. And if I press 1, it's sorted with index, but the data is not sorted. Okay, so that's basically what we want to aim for. After that, if you've read your question, you can see there's a display array function. If I quickly go all the way down here, you will see this display function basically displays the frequency index values and the frequency data values. So let's quickly just jump to this one and just check if we can complete the functionality for the first two screenshots there. So all the way up, I'm going to go to function 8. So let's quickly read it. So display array function prints the contents of the integer array along with the text label text. Each element of the array is printed in the same line, separated by tabs. This function is useful for displaying the array elements in a formatted manner. So we have again this text array that's basically our heading. So we will just do a %s again, and then thereafter we can do a for loop and I is equal to 0 to traverse through all the values, and we've got a size and then an I plus, and then what we will do here is I will just go and increment, or not increment, display each element and then separate it with a tab space. So a tab space, and then we will have our array I, and then printf, and then we will have a new line there at the end. So it's basically very simplistic display function. So I'm just going to save this and let's see what will happen. So now that we've implemented the display function, so what will happen here is something is going to happen, and we just need to confirm that everything is working as it should. So let's quickly go and check. So I'm displaying the graph sorted by frequency index. Let's go and check here. %s, char text, everything looks okay for me at this point. And the last thing is, oh, I just forgot to add this parameter there, text. Otherwise, it's going to give me an error there. So now if I run this, let's quickly go and check what's going on at this point. So graph, I'm displaying the graph sorted by index. Here you can see it's sorted by index, not by data. If I press 2, it's going to sort it by data and not by index. Okay, and there is just the first basic part of our program. Now we can continue basically to the last few functions. That's function 5, 6, and 7. And let's go and look at 5, 6, and 7. So function 5 is the data average function. So the data average function computes the average of elements in an integer array ARR and the size. It sums all the elements in the array and then divides them by the size of the array calculated by the average. The function returns the average as a floating point number. So this is a function that will go and return it, and there may be no printf or scanf functions in this function. So very simple, we just need to go and create a sum variable, and we need to initialize it to 0, very important. Then thereafter, we need to go and traverse through each element in this array. So we just do a basic counter control variable, and then thereafter we will just do a rolling sum where we will add the index value into sum each and every time. After that's done, what we will do is we can just go and return the sum value divided by the size. Okay, and that's going to give us the average. Now this is an integer and this is an integer, so what we will need to do is we will just need to go and typecast as well, maybe this sum to a float, so that we can actually get a floating value that will be returned. Okay, so let's quickly just go and build and run this, and let's see what will happen and if we get the correct results. So I can display this, but let's go to, oh sorry, I pressed 4 for exit. I'm just going to run it again. So you can see I can display the actual values, and then if I press 3 for the average, you can see that the average is 50.01. Okay, so thereafter we can also go and determine the data min function and the data max function, and they are very, very similar, almost the same thing. So it's just one line that changes. So what we can do here is I'm just going to call this int min, and I'm going to set this to the first index of this array. So there's method in the madness so that I don't have to initialize this min to a certain number. So basically what this function will do, it's also going to traverse through each element of this array, and then it's going to traverse from I is equal to 0 to I smaller than size, and then I plus plus, so basic for counter control for loop again. Then inside of this function, for this for loop, inside this for loop, what we will do is if min is bigger than this index, so array I, then we need to go and change this to array I. So if min is bigger than this index, we need to go and change min to this value so that this is now the new smallest value. So array I, and we've basically updated this, and after we are done with this, we can just go and return min. And this basically is an exact duplicate for data max. So if I do data max, I can just go and change the paste. We can just go and change this variable int min to max, and to max, and max. Okay, and the one thing is, if max is not bigger, but if max is smaller than this one, array I is going to be our new maximum value, and that should basically cover it for functions 6 and 7. So now after that, if I build and run this, what will happen here is I will actually have my display graph sorted by index. As you can see here, the index, but the data is not sorted. I can press 2 to sort it by the data and not the index. And if I press 3, it's going to give me the average. And the average is 46.55. The minimum is 0. So let's quickly go and see the frequency data values. So the minimum value and the maximum value. So we've got a 99 and a 0 that's in there. We've got our frequency index values and our frequency data values. And after that, we can go and exit as well. And then we are done with the program. So as you can see here, we've got our C file, and we've now created our .h file. And basically, if you've done everything like this, this should more or less give you a 100% pass mark, because everything is working as it should. So that's just the basic summary of the EV2 or evaluation 2 of ES216AB 2024 for semester 1. So I hope this helps you. Just remember to do your indentation. Another thing to remember is if there's one line of code below a control structure, then you don't have to have brackets. For instance, in this case, you don't necessarily need brackets, but if you are comfortable rather to use brackets so that you know that it doesn't make any problems, you are more than welcome to add that brackets, but it's really not needed. And then remember your indentation to show what's inside of what structure. Very important, so it makes your program very nice and neat and easy to go and read. Also, make sure that you remove all the unneeded, unwanted spaces so that everything is nice and neatly spaced, so that you can quickly go and review this code and make sure that everything in there is actually working as it should. So that's it for me, ladies and gents. I hope this helps you. Going through this again, make sure that you understand exactly how I got to these results. For instance, also the generate random values, and to determine the frequency, go through it a few times, make sure that you understand the logic so that you will be able to do this in future evaluations. But that's it for me. Thank you very much for joining. I hope this helps, and I hope you have a wonderful day. Bye-bye.